In this series of videos, we are going to work with rational expressions. We'll perform operations including simplifying rational expressions, working with complex fractions, adding, subtracting, multiplying, and dividing. Let's get started on reducing fractions. When we reduce fractions, we look for common factors in the numerator and the denominator so that they, what we call, cancel out. However, technically, they don't just cancel out and become zero. They cancel out because anything over itself is a factor of 1. So I'm going to demonstrate that here. We know that x squared minus 9 is x plus 3 times x minus 3. And we know that the denominator has a greatest common factor of x, giving us factors of x and x plus 3. Now, because these are all factors, common factors, I'm going to rewrite this so that you can see x minus 3, x plus 3. I just reversed the order, and then x times x plus 3. Anything over itself is a factor of 1. So what we see as canceling out, that's really multiplying x minus 3 over x times a factor of 1. But I'm going to refer to this as canceling. It's kind of the shorthand terminology. Now, in order to work with this reduction of fractions, reducing our fractions, we're going to look at properties of negatives with our fractions. And also just with our terms right here, b minus a is the same thing as the opposite of a minus b. So if you think of this in terms of numbers, if I have 5 minus 2, we know that that's 3. But if I want to write this 2 minus 5, that's not the same thing. 5 minus 2 is not equal to 2 minus 5. Positive 3 on the left is not equal to negative 3 on the right, but it's the opposite of negative 3. So that's what this property says here, that if I have b minus a, but I really need a minus b, I can reverse the order, but I have to put this negative out front. So I have to take the opposite of that flip. Many times that's going to look like what we see over here. We'll have 2 minus x when we really need x minus 2. So we're going to make it x minus 2, but we'll put that negative out front to take care of that so that we have an equal balance of our equation. Okay, a minus b over b minus a, well, that's the same thing as a minus b over, if I need b minus a to be a minus b, I can reverse the b and the a, but I have to put a negative out front. Now I have a minus b over itself, which is 1, and then I have this opposite, so I have the opposite of 1, which is negative 1. And many times we will need that when we have variables. So 2x minus 5 over 5 minus 2x, it's close to being perfect. It's close to us being able to just cross them out and say that it's 1, but not quite. So we have to take this 5 minus 2x. We could actually take the 2x minus 5 and make it 5 minus 2x. But then we'll put the negative in the numerator. And then we have 5 minus 2x in the denominator. The 2 cancel out, and we still have negative 1. Okay, so let's put all of these ideas together and work on our first problem. We want to simplify 4 minus 3x over 15x minus 20. Our first step is to factor both the numerator and the denominator. Then we're going to look for common factors. So look for common factors in the numerator and the denominator to equal 1 or to equal negative 1, as demonstrated above. So 4 minus 3x, we're going to leave that because they don't have any common factors. But the denominator, 15x minus 20, 5 goes into both of those. So we're going to take out a 5, we'll factor that out, and that's going to leave us 3x minus 4. Now our 4 minus 3x over 3x minus 4 is equal to -1. So we cancel those factors out and we replace it with -1, which simplifies our fraction to be -1/5. Okay, here's one for you to try. 3 minus 2x over 8x minus 12. Go ahead and press pause, and when you're ready to look at the answer, press play. Okay, checking your work, you should have 3 minus 2x over 4 times the quantity 2x minus 3, which reduces to -1/4. Now, I love, this was -1/4. Let's write that down right here. It's the second time that my program has kind of just gone out on me. Simplify x cubed minus 8 over x squared minus 2x. Now, what I love about this is that the better you are at factoring, the more fun these problems are. X cubed minus 8, that's the difference of 2 cubes. X cubed is a cube of x, and 8 is a cube of 2. So we're going to have x minus 2 times x squared plus 2x plus 4 in the numerator. In the denominator, we have a greatest common factor of x times x minus 2. Our x minus 2 over x minus 2 is a factor of 1. So our answer is x squared plus 2x plus 4 over x. Now normally I would try to factor the numerator, but remember when you factor your difference in sum of cubes, the trinomial is not factorable as long as you don't have a greatest common factor. Okay, here's one for you to try. Go ahead and press pause, and when you're ready to come back and check the answer, press play. Okay, here you should have gotten x squared plus 3x plus 9 all over x as your final answer. I'll show you the work. We have a greatest common factor of 3. In the denominator, we have a greatest common factor of 3x. The numerator here can still be factored. It is x minus 3, x squared plus 3x plus 9, all over 3x, x minus 3. The x minus 3's cancel, the 3's cancel, and that's where we get x squared plus 3x plus 9 all over x. And like I said, these just give us a lot of opportunity to practice our factoring skills. So we're going to start with factoring that numerator. The numerator is going to factor to be x minus 2, x minus 4. And the denominator, I have two terms. They both have an x minus 2 in common, so we factor that out, leaving us a plus b. The x minus 2's cancel. They become a factor of 1. So our answer is x minus 4 over a plus b. And here's one for you to try. Go ahead and press pause. And welcome back. If you got x minus 2 over y minus z, hot dog. Our factors were x plus 3, x minus 2 in the numerator, over x plus 3, y minus z in the denominator. And the denominator is a factor by grouping situation. Okay, we'll come back in the next video and we're going to work on multiplication and division.